Rational expressions are the relations of two polynomials uh, where they're being divided by each other. And so what we're going to do in this video is look at different ways that we can simplify rational expressions and some of the rules we need to follow. So one of the things we need to do when we have a rational function is we need to start out by identifying values that would make this function or expression undefined. And in this case, if x was 0, then we'd be dividing by 0, which would mean this is undefined. So we do need to identify, first of all, that x in this case cannot equal 0. Then we can go move on with the simplification and doing that by dividing out things that are in common. So for example, 36 and 42 both have a common factor of 6. So I could write the values here as 6 over 7. And we see that x squared divided by x cubed would leave us with an x in the denominator. And so that is the simplified version of that. So go through each of these examples. Once I show you this one, pause the video, try the one on the right, see how you do, and then I'll post the answer for you. All right, so that one's 4 over 3x as long as x is not 0. Let's move on to this next one here. We have 15x minus 3 over 24. All three of those terms have a common factor of 3. Now notice I said all three and not just two of them. If you want to factor out a 3, you need to factor out all three terms. And so if I divide a 3 here through each of them, I end up with 5x minus 1 all over 8. Now there's nothing in the denominator that would make this undefined, so we can just leave it at that. So pause the video, try the one next to it. Okay, this one had a common factor of 5, so we end up with 9 over 2x, 2 minus x. This next one here, we see we have an x minus 1 in the denominator and an x minus 1 in the numerator. And because we know that the denominator cannot be 0, first we have to state that x cannot equal 1. And now, because I have two similar terms, those will divide to 1. And the simplified version of this is I'd be left with is x plus 1. So again, pause the video, try the one on the right. Okay, so you get x plus 2 as long as x is not 3. Let's move on. So here we have an x plus 2 times x minus 3 and 3 minus x. And on the surface, it doesn't look like there's anything in common here. And so one thing we can do, though, with something like this is if we factor the denominator, if we factor out a minus 1, what we can do is get a term similar to the one in the numerator. I'm going to first identify values that x cannot be. So in this case, we know that x cannot equal 3. And then let's factor out a negative 1 from this denominator here. So minus 3. If I factor out a negative 1, I end up with negative 3 plus x, which is the same thing as saying x minus 3. So our denominator is the same thing as saying negative x minus 3. And now I can divide these to 1, and I'd just be left with x plus 2 over negative 1, which is the same thing as saying negative x plus 2. So this would simplify to negative x plus 2 as long as x is not 3. So try the one on the right here. Okay, this time I factored out negative 1 in the numerator and ended up with negative 2x plus 4 as long as x is not 1. Okay, we'll keep going here. Sometimes it's not super obvious where the common factors are or where we can divide out easily. But if we do a common factor in the numerator here, you see we get 3x squared plus 1 all over x squared plus 1. Now this denominator here does not have any real solutions that would make this undefined. So we don't have any restrictions on x. And we could divide x squared plus 1 divided by x squared plus 1, and we end up with 3 in this case. So pause the video, try the one on the right. As we can see, a similar thing happened. 2x squared plus 1 does not have any real solutions for x when it's 0. So in this case, this would simplify simply to 2. Here we have a binomial above a quadratic trinomial, so we should always try to factor the quadratic trinomials first, and we get x plus 2, and then I'm looking for two numbers with a sum of -1 and a product of -6, and so that's going to be x minus 3 and x plus 2. And so this tells me right away I can see the values that x cannot be. So in this case, x cannot be 3 or -2, because that would make the denominator 0. And now I can divide out the two similar terms, and I end up with 1 over x minus 3. So pause the video and try the one on the right. And we see this one simplifies to 1 over x plus 2 as long as x is not 4 or -2. In this example here, we have two quadratic trinomials, so we're going to factor both. So we're looking for first a sum of -4 and a product of -12, and that's going to be x minus 6, x plus 2. And then we have -1 and -30, so that's going to be x minus 6 and x plus 5. So I can see here x cannot be -5 or 6, because that would make the denominator 0. But both the numerator and denominator have an x minus 6, which would divide to 1, and we'd be left with x plus 2 over x plus 5. Okay, pause the video and try the one on the right. Okay, so we see we end up with x plus 3 over x plus 1 as long as x is not -1 or -2. All right, this last one here, I'm going to look for some common factors because I have a cubic in the denominator there, but they all have an x term, and same in the numerator. So the first thing I'm going to do is factor out 4x from the top. And so we have 4x, x plus 7. And then in the denominator, we're going to have x squared plus 4x minus 21. And I need to keep going with the factoring now. I have a quadratic I can factor. So I got 4x, x plus 7, I have an x here, and I'm going to have x plus 7, x minus 3. And so now I have three values that would make this undefined. I would have x being -7, 0, or 3. So those are my three undefined values. And now I can start dividing things out to 1. So the x and the x would divide out to 1, and the 2x plus 7 terms, and I would be left with 4 over x minus 3. So pause the video and try the one on the right. And in this case, I get x plus 2 over 2, as long as x is not 0 or -3. So when simplifying rational expressions, you're looking for things that will divide out in both the numerator and denominator, divide to 1, and that way you can simplify more. Make sure you always include the values that need to be excluded.